The idea that many of the explanations for the mysterious forces of gravity, known as the dark matter effects, don't actually require any form of elusive dark matter itself is one of the most revolutionary challenges to modern physics, especially within the context of the energy filament theory. The traditional physics view suggests that galaxies are spinning far too fast for the amount of visible mass present to keep them intact. This leads to the assumption that there must be a huge, invisible mass, called dark matter, to supply the gravitational pull necessary to hold everything together. However, according to the energy filament theory, what is actually invisible in the universe isn't matter itself, but rather an averaged gravitational background, something that is not considered in the conventional dark matter model. So, where does this invisible force come from? Throughout the universe, there are various unstable particles that live for extremely short periods. Scientists in laboratory settings have already discovered hundreds of such particles. These particles are incredibly short-lived, but in that short span of time, they undeniably affect the energy sea, contributing to gravitational forces. When the generation rate of these short-lived particles in a particular region is consistently high, their gravitational effects begin to accumulate over time, and this creates a type of gravitational field that is invisible to us. A useful analogy to understand this is walking in a light rain. Each raindrop is insignificant on its own, but when millions of them hit your umbrella, you can feel the weight of the rain. The gravitational effect of these unstable particles works in a similar way. Individually, they're hardly noticeable, but collectively, their effects are strong, and they create the illusion of dark matter when observed from a larger scale. Now, where do black holes fit into this picture? In the energy filament theory, black holes play a key role in this process. They generate enormous disturbances in the tension of the energy sea around them. This disturbance, in turn, increases the likelihood that unstable particles will form and deconstruct in the region surrounding the black hole. These disturbances are not limited to just the black hole itself, but extends to the surrounding areas, including the outer regions of galaxies and galaxy clusters. These areas are where unstable particles are formed in unusually high numbers. The gravitational force in these regions is noticeably higher than expected, which creates the illusion of a large concentration of invisible matter, or dark matter, that doesn't actually exist as a separate substance. Therefore, in the energy filament theory, what we experience as unseen gravity is simply the combined effect of the gravitational pull of these unstable particles and the enhanced gravitational effects caused by the turmoil around black holes. These forces can mimic what is commonly attributed to dark matter, but without the need for any exotic substances. This episode provides an initial overview, but we'll go deeper into the concept of unseen gravity and the illusion of dark matter in the coming episodes, where we will unpack these ideas more thoroughly across an entire season of our series. In the next episode, we'll take a closer look at why black holes produce a type of unique redshift that stands in stark contrast to what mainstream textbooks have taught us. Tap follow, share it on New Physics, Clear Universe.